going to briefly report on this paper. I have discussed marine heat waves already, and 2023-24 was full of marine heat waves. These have been very warm years, and marine heat waves, of course, have become very popular now in terms of publications, and people are already starting to talk about predicting them. I've raised issues about what can we do with those predictions. If you say a coral is going to get bleached or a fishery is going to get affected, what can you do in reality to act with that information? This is very important on land heat waves, last mile gaps for flood forecasts, early warnings, heat waves. Cyclones work very well with evacuations and so on, but this paper nicely lists the kind of actions that are possible and looks at whether those responses were generated by the information available. That's a very key thing to understand. If you think about floods in Valencia, lots of damages, horrific pictures of mud, rivers of mud floating over cars, and many people died. But was there a prediction? Was it accurate? Was there action taken? And so on. Those are the key questions. There is always a series of attribution papers that talk about how the floods or heat wave or droughts were made worse by global warming, but these could be somewhat more useful in my mind. Okay, so let's look at this. If I go to presentation mode, ocean extremes as a stress test for marine ecosystems and society. In 2023-24, widespread marine heat waves associated with record ocean temperatures impacted ocean processes, marine species, ecosystems, and coastal communities with economic consequences. Despite warnings, interventions were limited. Proactive strategies are needed for inevitable future events. So we talk about increasing extremes, duration, intensity, frequency, and scale of these hazards and so on. But are we getting better at predicting them on one hand and acting on those predictions and early warnings on the other hand? So marine heat wave activity in 2023-24 in ecoregions. As soon as I start talking, somebody remembers me, so I start having hiccups, right? So in ecoregions and in the open ocean, the brownish colors in the open oceans, and there are many coastal ecosystems, fisheries, and so on affected. Most marine heat waves in summer of 2023-24. So these are the colors in the Indian Ocean, Pacific. West Pacific is, of course, very warm. There are some in the Atlantic as well. Top decile marine heat waves days in summer 2023-24 in the this is like an orangish color, and then there is a yellowish cover. Ecoregion boundaries are also shown here, and the other here is the ecoregion average in terms of strong or above marine heat wave days, going from 0 to 30, and here ecoregion average marine heat wave days as well. And here you are looking at top locations where summer MHW days, marine heat wave days, were either the highest or in the top decile during the summer of 2023-24. So June 2023 to September 2023 for the northern hemisphere, and December 2023 to March 2024 for the southern hemisphere. So you can show them together. And here we are looking at average number of marine heat wave days within ecoregions for the summer period of each year. For all marine heat waves, strong and greater marine heat wave categories based on satellite record commencing in 1982, so baseline. Marine heat waves are calculated with some methodology that's in the paper, and so on. So ice cover areas have been excluded for this, so some details in the methodology. So this slide is important because we are now looking at many regions. There are lots of numbers. I don't want to try to map them one on one, but let's look at these marine heat wave categories in these regions, right? In the greenish color, they are biological. In the bluish color, they are physical, and in the dark blue color, they are societal. Okay, so the interventions include proactive and reactive, and there are cases like A, B, C, and so on, where warnings issued, coral conservation, commercial fisheries cancelled, quotas issued, government subsidies provided, new and increased commercial fisheries, increased tourism opportunities, and species collected, monitored for conservation. So it's not all about preventing livelihoods or activities, but also seeing if there are increased tourism opportunities and commercial fisheries being expanded, subsidies being provided, and so on and so forth, as well as collecting and monitoring species for conservation. So there are many actions possible, many were taken. In the biological category, we have coral bleaching, harmful algal blooms, mass mortality event, species range shift, habitat loss, reduced primary productivity, reduced growth and reproduction, increased cetacean stranding. So you can look up the cetaceans, which are basically like dolphins and so on. Diseases, of course, and physical, tropical cyclones or storms, atmospheric heat waves, flooding, oceanic currents. What are the societal impacts? Tourism, fisheries, aquaculture, and infrastructure. Okay, so steps for preparedness, preparation, and response goes from 1 to 7. Establish baseline and deliver a forecast. Assess risk and plan responses. Respond to forecast. Adjust to cope with the hazard. Evaluate the impacts in the aftermath. Collect new baseline data to see how the system got affected, and reset quotas and activities for the new situation, right? So here is the seawater temperature, here is time. So you are going from this is the curve showing MHWs, of course, in terms of seawater temperature. When you reach these thresholds, you are in the declared marine heat wave condition. Can last for several months or longer because ocean is deep, has high heat capacity, unlike the atmosphere. Even in the atmosphere, you can have these atmospheric domes forming that can last for weeks and trap heat. So reactive response plan, anchovy fisheries closed. Example, handfish conservation project here. Proactive response plan, recovery team develops action plan, and you have here threshold, usually 90th percentile. So you are going on in time here. So temperature is low, you're lasting for a few months potentially. Remember, this is schematic here, and mean seasonal temperatures with their range, right? So you have steps for preparation and response, proactive responses. So red handfish conservation project in Tasmania, reactive response plan for anchovy fisheries closure in Peru, and so on. So basically you have identified steps for preparation in response to early warnings, and depends on the lead time scale, but you can have ideas about heat wave season so that you can be ready for that season before any early warning is issued, so that when the warning comes you can go with these steps. Okay, so there are lots of details here that I will skip, but these are proactive response plans. So forecast delivered, providing 3-month warning. Recovery team for critically endangered red handfish develop action plans. Options include removal of individuals from natural habitat restoration, closure to human activities, and in the reset quotas and activities in terms of proactive responses, you have assess success of intervention measures that are already taken and adjust future action plan accordingly, so that even the fishermen know why they are getting a changed quota and so on. In terms of all these early steps, establishing baselines, assessing risk, and so on, responding forecast, no action in terms of anchovies of Peru, but adjust to cope. Exploratory fishing at the beginning of season shows high number of juveniles. Opening of fisheries first delayed and then later cancelled. So if the population where you are fishing is all juveniles, you want to wait till they become adults and hopefully are done breeding and then in the senescence phase, so that you can then capture them and consume them or do whatever commercial products with them. Second, in terms of evaluating impacts, the reactive response plan was Second season of year closes early before quota is reached. Second season of year closes early before quota is reached, as impacts are obvious. Fishermen receive government payout towards end of marine heatwave event, which means government had a plan to help the fishermen because of the impacts. Surveys carried out to inform quota for next season, and quota is adjusted based on survey results. So this is a good table. This is exactly why I wanted to cover this paper, because these also apply for hazards on land. They are just using marine heat wave as an example here because they had the data, but we need to also look at all these steps in case by case and then map many cases so that you can develop typologies of steps for preparation and response. For heat waves, cyclones, as I said, have worked very well because we have lots of experience and people are required to move when warnings come, alerts come, and orders come to evacuate and so on. And number of lives saved is very high in a place like India, or mortality is reduced to now very low numbers compared to a couple of decades ago. But other hazards like heat waves, still long way to go because people are not paying attention, old people are exposed and end up dying, and floods of course can hit very quickly, droughts can creep up, and different kinds of steps for preparation and response are needed. Okay, what are the ways forward then? Effective response strategies and interventions for MHWs rely on skillful forecasts at the required lead time and represent the most useful tool for decision makers. This is true for all hazards. Efforts in forecasting have improved in recent years, also true for land hazards. Although the skill of different forecasts varies globally, true for heat waves versus droughts versus floods versus cyclones. Across the 2023-24 period, forecasts were generally accurate, although there were areas where MHW activity was over or underestimated. Improving forecast accuracy will lead to greater confidence for proactive decision making, while longer range forecasts will extend the preparation window, but these take time. People have to look at the forecasts many times before they begin to get a sense of the uncertainty for themselves, and then they are very quick to act. Like hurricanes and cyclones, people don't hesitate to respond because they have had experiences or they know that the danger is very high. The NOAA has now, the National Oceanic and Atmospheric Administration in the US, which is having some issues because of the fund cuts and so on, but NOAA has now added 3 new alert levels to its Coral Reef Watch program, which acts as a warning system for scientists, conservationists, and managers globally. These advancements are made possible by the ocean's long-term dynamics and partially predictable ocean atmosphere feedback processes, particularly in the tropical regions. Understanding how recurrent climate patterns such as the El Nino Southern Oscillation influence sub-seasonal to seasonal predictability is crucial for developing marine heatwave forecast models with lead times of weeks to months. Achieving greater forecast skill will depend on improving initial ocean atmosphere conditions used in forecast models, so data are very critical, requiring enhanced observational networks and real-time reporting of ocean data, which is getting hammered by fund cuts as well. While progress is clearly being made towards forecasting and proactively responding to impending marine heat waves rather than reporting impacts after the event, there is still much room for improvement always. Efforts should be enhanced on global and regional levels to build capacity to use and disseminate recently developed forecasting and warning systems. At present, national briefings and proactive planning for MHWs is largely limited to locations where these events have previously had substantial impacts resulting in major socioeconomic losses, and where funding and infrastructure allow for research and interventions to be carried out. Obviously, but the point is that with global warming, you are now having more MHWs in newer places, so you have to be proactive in terms of not just relying on historic experiences. Proactive targeted response plans such as red handfish conservation efforts, coral species relocation to cooler waters, and shift in fishery activity could be implemented much more widely. So it's very important to know what can be done. Ecological resilience to MHWs can also be improved by reducing other stressors, creating refugia or adapting conservation activities. So we need to get prepared, but this is not an easy task. Developing new interventions and improving access to both early results and long-term outcomes of the intervention trials, such as relocating vulnerable species, will allow for faster learning, increasing opportunities for successful interventions in the future. Broadly disseminating such information across sectors through stakeholder engagements, industry briefings, and public guidance will further build capacity for proactively responding to MHWs in the future. As I said, I'm reading this because these things also apply for all the hazards on land, and even the responses on land preparation and recovery have to improve by a lot. The past 2 years I'm having emotions. Past 2 years, 2023-24, have been the warmest on record across both land and ocean, and increases in MHWs due to anthropogenic heating are expected to continue. There are challenging times ahead, and there is a pressing societal need to better prepare for unprecedented ocean heat extremes. Response plans are being developed and tested, albeit in very few regions. Where interventions are being trialed, their effectiveness should be rapidly shared to enable use in other locations and to deploy it at effective scale. So transferable solutions are always important. Lessons learned in one place should be codified to be translated to other places, transferred to other places. This will require alternative communication to the traditional scientific literature, such as reporting impacts and interventions via marine heatwave websites. So there is one here, marineheatwaves.org. Rapidly improving preparedness and proactive responses for future events is paramount. Okay, so it's a useful message, and hopefully you can go back and read the paper, because as usual I'm very brief and I will leave it here. Okay.